Hello everybody. Next we're going to look at how work is converted to energy. And there's a statement right here that I think summarizes it pretty concisely. That is, anytime work is performed on a system, energy is added to that system. Now the types of energy we're going to talk about a little bit here can vary, but anytime you're doing work on a system, you're adding energy to that system. Say for instance it's marker. If I'm elevating this marker, I'm doing work on it. If I did work on it, I've added energy to that marker. And we'll talk about what specific type of that energy that is in a little bit here. But the first type we're going to talk about is called kinetic energy. The word kinetic means motion. So kinetic energy is simply energy in motion. And the formula for kinetic energy is 1/2 mv squared, where m is your mass and v is your velocity. So an object at rest has zero kinetic energy because its velocity would be zero. But an object in motion has some kinetic energy. Now, say for instance we take an object whose mass is 3 kilograms and is traveling at 2 meters per second. We want to know how much kinetic energy does it have at that moment. Well, just using the 1/2 mv squared is 1/2 your 3 kilograms times your 2 meters per second squared. Now keep in mind, the only thing being squared here is velocity. You're not squaring the entire side. So you have your 2 meters per second, and that is squared. So if you type it in, 0.5 times 3 times 2 squared, you end up with 6. Now the unit for energy in addition to work is also in joules. So say for instance, whenever I push an object, I've done work to it, or I'm pulling it as we cross a room. Say that was the case here, I was pulling a 3 kilogram object across a room at 2 meters per second. At that point, I've done 6 joules of work. How do I know? Because it has 6 joules of kinetic energy. So in other words, how much work is performed on the system, that's how much energy is added to it. If I did 2 joules of work elevating this marker, I added 2 joules of energy to this marker. So however much work is done, that's how much energy is added. Something to keep in mind when we look at our next videos, we'll talk about the opposite of kinetic energies. Energy to motion would be potential energies, which are going to be energies at rest.